Good morning. All right, today we are going to start to break down sequences, and we're going to look at a very specific type of sequence today called an arithmetic sequence. So first thing we need to do is define an arithmetic sequence. An arithmetic sequence is a sequence in which there is a common difference between terms. So in other words, to get from one term to the next, we're adding or subtracting the same number every time. This is a good example of an arithmetic sequence because every time we are adding 4 to get from one term to the next. Adding 4 to get from one term to the next. And so that's what makes this an arithmetic sequence. So we can determine if something's an arithmetic sequence by looking at, are we adding the same thing every time? So what do I have to add to 2 to get 5? 3. Add to 5 to get to 7 is 2. So automatically, I don't even have to check the next one. I know that this is not arithmetic because we don't add or subtract by the same thing every time. If I look at this one, I'm going to check it, and I've got, okay, how do I get from 48 to 45? I subtract 3. I get subtract 3, and I see that I'm doing the same thing every single time. So this is going to be arithmetic. Okay, so now we're going to look at how to write formulas. And so we looked yesterday at how to write a recursive formula for an arithmetic sequence like this. A sub n equals a sub n minus 1 plus d, where d is the common difference. But we don't usually know the previous term. If I ask you to find the 107th term, you'd have to know the 106th. But you probably don't have all 106 terms. So you'd have to go all the way back to like the third or the fourth term that you do have, and keep adding the same value over and over. So instead, it's better to use the explicit formula. And so that's going to be this guy right here. A sub 1 is the first term. Remember that whatever this number here is tells us which term we're looking at. And d is the common difference. In other words, what value are we adding or subtracting every time? So let's practice with this. Find the 73rd term. The first thing we need to do is to write a formula because I don't want to have to go through and do this pattern over and over and over again. So I'm going to say I need two important things. I need my first term and I need my common difference. So my first term, that's pretty easy. It's 12. It's the first thing written. My common difference, or my d value, is going to be negative 5 because I'm subtracting 5 every time. So to write my formula, I would do a sub n equals the first term plus n minus 1 times negative 5. I'm going to put this in parentheses to remind myself that I'm multiplying everything by negative 5, and I'm not doing n minus 1 and then subtracting 5 at the end. So I want to make this look a little bit cleaner. So I've got a sub n equals 12 plus, I'm going to distribute this negative 5 to everything. And then simplify a little further is going to give me negative 5n plus 17. So there's my formula, and now I can substitute in this 73 as a value. All right, so if I do negative 5 times 73, I should get negative 365 plus 17. Oh, so really, actually, I'm going to go back here. Instead of saying a sub n, really I should be saying a sub 73 because I'm saying the value of the 73rd term. So the value of the 73rd term, and then a sub 73 equals negative 348. And that would be my answer. So yesterday it didn't really seem like writing these formulas made much sense or took a lot of effort. However, we see today that an explicit formula is very helpful because it allows us to find the value of one of these later terms, like 73. All right, so a sub 1, that's what we always start with. A sub 1 is 4. My common difference is a positive 3. I'm adding 3 every time to get from one term to the next. So I get a sub n equals 4 plus n minus 1 times 3. Now, some people will say, can I just leave it like this in this format and plug in 73? And the answer is yes. You just have more steps to go through in terms of using the order of operations. And that's why I like to simplify it a little bit further up here. So I'm going to get 4 plus 3n minus 3. A sub n equals 3n plus 1. And you could put 1 plus 3n, it doesn't matter. I just like my variable to go first. So I like this formula just because I think it looks cleaner and it makes it go a lot faster when I substitute in 73. Speaking of substituting in 73, let's do that right now. We've got 3 times 73 plus 1. If we do 73 times 3, we get 219. Plus 1, we get 220. There's our 73rd term. All right. Why don't you pause the video, try this one, and see how you do. Come back and we'll check our answer together. All right, so I need to find my first term and my common difference. My first term is negative 7. My common difference is positive 4. I'm adding 4 each time. Sometimes with the negatives it can get a little tricky. I'm not going to give you a trick problem where I say find the 73rd term and then go, haha, just kidding, it's not actually arithmetic. You can assume that if I'm saying find the 73rd term, you can like count that it is a sequence. I'm not going to be tricky on this. Okay, so you can look here and say, okay, plus 4, and then check it for the lower ones. Yep, that works all the way across. You're not required to find the pattern based on the first two numbers. So I'm going to get a sub n equals negative 7 plus, n minus 1 times the common difference of 4. So that's going to give us 4n minus 4. A sub n equals 4n minus 11. So there's my formula, and then I'm going to have a sub 73 equals 4 times 73 minus 11. 4 times 73 is 292. When I subtract 11, I should get 281. All right, and that's it. That's arithmetic sequences. So get on Google Classroom and look at your assignment for the day, and let me know if you have any questions. Bye, guys.